morning children, welcome back to your chemistry class. So yesterday we discussed about the nomenclature of these coordination compounds. Okay, so today I will give you some more practice on coordination compound, their nomenclature, and then we shall discuss about the isomerism also of these compounds. So let us begin. Let us do some more nomenclature. Name the following. Okay, so the first one could be CuH2O whole twice NH3,4SO4. Name this compound. So it will be, now amine is also there and aqua is also there. So whose name should be written first? Amine. So the name becomes what? Tetraamine. It is di-aqua. Then copper is there. So copper oxidation number will be 2. Sulfate is 2, no? In the Roman number. Then sulfate. Clear? Let's take another question like K3FeC2O4 whole thrice. Now name this compound. So potassium is there. So how do we write down? Firstly, remember we should not begin with the capital letter. This is also something that we don't have to do. So begin with a small letter. Okay. Potassium. Then what it is? The ligand has to be mentioned over there with tri, bi, whatever. So tri, what is this? This is oxalate. So how should we write oxalate when it is inside this square bracket? It will be called as oxalato. So trioxalato. Okay. Now look at the central metal atom. It is iron, ferrum, and it should end up with 8. So it will be ferrate. Ferrate. What is the oxidation state of it? Calculate and check. It will come out to be 3. Okay. Then take another example. Okay. COCl2, then NH3 whole 4, then chromium CN whole 6. Now name this compound. So let's begin. Tetraamine. Then first we are going to write down the name of this compound. Tetraamine dichloro. Okay. So now chloro it will be or chlorido. It is inside the bracket, no? So it will be not chloro. What it will be now? Chlorido. Cobalt. What is the oxidation state of cobalt? Check over here. This is 3, so it will be 3. Then we come to the next square bracket. Hexacyanochromate. Find out the oxidation state of chromate. How much? 3. So this will be the name of the compound. Now draw the structure of number 1. Let's take for example penta aqua nitrosonium iron 1 sulfate. Okay, write down the formula of this. So what does it say? Penta aqua. That means aqua, which is penta. Now this has to be inside the big bracket. Nitrosonium iron 1 sulfate. So what is nitrosonium? This is NO. This is 1 iron. Close the bracket. Sulfate, that means it has to be written outside. Okay, so let's take another example. Aqua Sino bis. What is bis? Ethane 1,2 diamine. Okay, this is ethane 1,2 diamine cobalt 3 iron. When I'm writing iron, do remember what I'm going to do at the end. Okay, so aqua cyanobis cobalt 3 iron. So how are we going to write down? Make the big bracket over here. It is an iron, so all are going to come into a big bracket. Okay, so we write down cobalt, which is the central metal atom. Then aqua means only one, there is no bi or tri, so only one water is there. Cyano, what is cyano? Cn, which is also one because it is not written bi or tri. Okay, then bis, ethane 1,2 diamine. How do we write this? We write this ethane 1,2 diamine as En. Okay, and this is iron. So this is iron. So what iron? It is 2 plus. Clear? So with like this, we are going to draw the structure of the given compound. Now we are going to start off with isomerism. Let us begin with isomerism. Okay, what does this word iso mean? Iso means equal and merism means part. So the compounds which have same molecular formula, different physical or chemical properties, right? Then the structures, they are termed as isomers and the phenomenon is termed as isomerism. This much you already know. So the coordination compound, the isomerism, is divided into two parts. The first is the structural isomerism that we need to study. Structural isomerism. Okay, and the second one is stereoisomerism. Okay, there are two parts of isomerism over here, structural isomerism and stereoisomerism. In structural isomerism, we are going to study about ionizational isomerism. We need to study about hydrate. Then the third is coordination isomerism. Then the fourth is the linkage isomerism. The fifth is the coordination position isomerism. Okay, so we have to study about these 5 isomerism under the heading of structural isomerism. And stereoisomerism is of further 2 types. What are they? This is geometrical, sorry, spelling went wrong, geometrical isomerism and optical isomerism. Okay, so I begin with the structural isomerism first. I will finish all these 5. If time allows, then I am going to continue with the stereoisomerism also. So let us begin with the structural isomerism. Okay, structural isomerism. And in structural isomerism, which was the first one, what do we mean by structural isomerism? First and foremost, let us understand where the formula will remain the same, but the structure is going to be different. Then they are termed as structural isomerism, right? Now why the structure is different over here? Because in the coordination sphere, remember coordination sphere, I had told you this, the square bracket, inside the square bracket, this is the coordination sphere, and the outside one is the ionic sphere. Don't forget that. So in the coordination sphere we will have different ligands over here. Therefore when different ligands are there, definitely they are going to affect the structure, and thus it is called as structural isomerism, right? So dealing with the first structural isomerism, I am going to talk about ionizational isomerism. So over here they have same molecular formula, okay, but they have different ions. Different ions are formed when they are dissolved in water, okay. So for example, should I write it down over here first and then I'll give it to you? Have same molecular formula but different ions are formed when dissolved in water. Is this point clear? Now let's take an example over here, like NH3 5SO4Br, okay, and the other one will be cobalt NH3 5, I write Br inside and SO4 outside. So now what is this? This is your secondary coordinate sphere and this is your primary coordinate sphere. Always remember, I am mentioning it over here so that you don't forget. This is your secondary coordination sphere and this is your primary coordination sphere, okay. So remember, the secondary coordination sphere, it always gives ion in the solution. The secondary coordinate sphere, they are going to give ions when they are dissolved in the water. What about primary coordination sphere? They are the ligands. They are directly attached to the central metal atom and therefore they do not dissolve. So who forms the ions? What did I have right over here? They both have same molecular formula, but the ions when dissolved in the water, they are different. So who is forming the ions when dissolved in water? The secondary sphere, and therefore in this case bromine ions will be formed and in this case the sulfate ions will be formed, and therefore it is called as ionizational isomerism. I hope this is very clear. Now we come to the second structural isomerism, that is the hydrate, okay. So what do we mean by this hydrate isomerism? When the compounds, they have same molecular formula, but when the coordination group is placed by water molecule, that means they have different number of water molecules present inside and outside, then they show hydrate isomerism. I'll write over here have same molecular formula but when a coordination when a coordination group is replaced by a water, okay, molecule, then we get a hydrate isomerism. In other words, we can say that there are different number of water molecules present inside and outside. That I am going to show you through the example. Let's start with an example. So I will give you a compound like chromium Cl3.6H2O. So this is actually the molecular formula, okay. Now this molecular formula can be written in three different ways. What are those three different ways? The first one, see, chromium this is H2O6Cl3. Okay, this is one way of writing it down. Another way of writing it down could be like this: H2O5, then one Cl will come inside, and Cl, there are 3, so it will write 2, and that one molecule of water goes out. Okay, then another formula could be like chromium H2O4, this one more chlorine comes inside, that means one less chlorine, and how many water molecules have gone out? 2. Okay, so when two chlorine ions are inside, then two water molecules have gone outside. When one chlorine ion came inside, then one water molecule went outside. When there was no chlorine inside, then all the water molecules were here. So all these have the same molecular formula, but they are written in different forms. What? When the coordination group is replaced by the water molecule, as I told you that now there is difference of number of water molecules that are present inside and outside. The third kind of structural isomerism is called as coordination isomerism. Okay, here when both cations or anions of the complexes are interchanged, then they form coordination isomerism. When both cations or anions of the complexes are interchanged, correct? Then they form coordination isomerism. Let's take an example. For example, CONH36 and CrCN6. Okay, this is one compound, and another one is CrNH36 and COCN6. Now see here, this is a cation, okay, and this is an anion. This is again a cation, and this is an anion, right? So over here, how can I say that this is an anion and this is a cation? This is very simple. Now look over here, chromium, the oxidation state is 3, okay, then plus 3, 1 minus 1 into 6 plus minus 1 into 6 is equal to x. Okay, so x will be equal to how much? Minus 3. So what? This is minus 3, and this has plus 3. So plus is a cation and minus is an anion. Over here also find out it is a cation and an anion. You will find that this is plus 3, this is minus 3. We can say that this is anion and this is a cation. Now coming to the fourth one, that is the linkage isomerism. What do we mean by linkage isomerism? This type of isomerism only occurs when the complex compounds, they contain the ambidentate ligands. Okay, so when ligands have two donor atoms, so it may coordinate by any of the atom, then it is going to show linkage isomerism. So what are those ligands which are ambidentate? Example could be like NO2 minus, isn't it? Then ONO minus, right? Then NCS minus, then SCN minus. So these are some examples which are ambidentane ligands. They have two donor atoms to coordinate with the other atom. Okay, so let's take an example like CO NH3 5 NO2 Cl2. This could be one, and another one could be, let me write it down over here only, cobalt NH3 5 ONO Cl2. Okay, so over here you can see they are ambidentane ligands and therefore they form the linkage isomerism. If you see over here, the donor atoms, they are different. Here it is N, here it is O. Followed? So this shows linkage isomerism. The fifth structural isomerism was coordination position isomerism. Over here, in polynuclear compounds, where ligand is attached between two central metal atoms, then interchange of the ligands between the central metal atom takes place. Then in that case, they are termed as coordination position isomerism. So I mention over here, in polynuclear compounds, where, what are polynuclear compounds? Where ligand is attached between two central metal atoms. Okay, then over here, interchange of ligands between central metal atom takes place, right? So let's look at an example like NH3 4 cobalt here, OH CO NH3 whole twice Cl2 Cl2. Okay, this could be one example. Another example, another compound could be like Cl NH3 3 COOH OHCO NH3 3Cl Cl2. So this could be another compound. So these are examples of the coordination position isomerism. What has happened over here? Only there is interchange of the ligand that has taken place. So what do we observe over here? That the ligand attached to the two central metal atoms, they have been interchanged, okay, between the central metal atom. So that was all about your structural isomerism. So that's all for today.